Hi there, welcome back. In a lecture, we created a mapping of founders where we are keeping the key value pairs of a number of the founder and the founder address. In this lecture, we'll create function to get all founders. Okay, so let's create here a new function. And maybe before that, I will just draw here very fast so that you can imagine these founders. Okay, my touchpad is other way around, so I cannot write here. Wait a second. All right, so now it should be okay. So you can imagine the founders now. It's mapping, right? So founders, founder is mapping. You can imagine mapping as a structure of key value pairs, right? So you have a keys, for example, key 1, and this will be mapped to some value. So this will be this address 0x. All right, and 7, 2, and the address of the user. But it's not as an array that it's indexing is going from the index 0 to 1, but mapping can be, basically key can be anything. And the key can be, first key can be 1, and the second key in the mapping can be completely something else. It can be number 100, for example. The next mapping key can be number 32, okay? And this will be mapping to some other address, 0x and 11 and so on, 0x to 3 and so on. So when you want to access the item from mapping, you need to actually know what key you want to access. Okay, so if I want to access here this address, I need to know that this founder is stored under the key of the 100. Okay, so that's a very important thing. And also the other thing is that I cannot iterate through this. I cannot iterate through the mappings. Okay, so you need to somehow order your keys so you can create an iterating structure. As for example here, where we are keeping the number of all founders, and that's basically my key, so I can keep the track of all of the founders basically thanks to this number of all of the founders, because they are starting from a 0, and as I'm adding founders, I'm just increasing it, and these ones are my keys to my mapping. All right, so just some notes about mapping. Okay, let's continue now, and let's create here a function to get all founders. So function, let's call it get all founders. All right, and we'll mark it as an external, right? So external, we don't have any intention to use here. Use it internally. It will be view and returns. We'll be returning here array of addresses. So address, array, and memory. You need to specify here whenever you're working with the arrays. Memory. Okay, now what I will do, I will create here empty array of all of my founders. So right here, address, array, memory. All right, don't forget to use the memory when you're working with the arrays, memory. And let's call this, we actually missing the name for a variable. Let's call it underscore founders. Okay, and let's create here a new array. You'll do it like this: new instance of a new array, new address like this, new array, and you'll specify how many items you would like to have in this new array. And I will specify here, this will dependent of the number of all of my founders. So I'll get this number of my founders, and I will get it here. So if I have here I have a number 5, I will create array of this length. Okay, so now what's left is iteration. We need to iterate through all of the founders, or simply we need to create an iteration loop where we'll be looping exactly the amount of the times as many founders we have, and we'll assign to this array the item, the founder of a specific iteration step. Okay, so let's do it. Let's write here iteration, normal for loop. It's very similar to JavaScript, so let's write here for loop. All right, and the for will look like this. We will have here first integer, so uint I, and I will assign their value 0. Then I will say here condition, I will say here y I is less than the number of all of the founders, so num of founders, and then simply increment I. So what will happen here? First, initially y is a 0. Let's say we have 2 founders, 0 is less than the number of the founders, so we are continuing in the loop. The next step, I will be incremented, we'll have here 1. 1 is less than the number of 2. Yes, we are continuing in the loop. So for 2 users, we are iterating through 2 times. Then it will increment to number 2. 2 is less than the 2. It's not, because it's equal, so it will jump out of the loop and it will continue here. Okay? So now, okay, we have a loop, and now we can get here founders. So this founders here. Okay, and at the index of y, on the current iteration, we will assign there are founders. So founders, we are keeping in a storage. So founders here, we'll be accessing here y like this. And simply from this function, we'll return here. So return all of the founders array like this. Okay, and that's the entire functionality. Okay, so we can try it out. Please, let's save it. Okay, here, let's run, actually have it here. I will need to remigrate, right? So I need to run here truffle migrate reset. And we can, while it is resetting, I will go here and I'll copy here a new function. So we'll be now getting all of the founders. So get all founders without any parameter. Okay, it should be remigrated, so I will clear it out. I will run here truffle console. All right, and after that, I will create an instance, copy this. Okay, let's add funds. One fund, second fund, all right. Okay, and now instance get all funders, and I will get an array of all of my funders now. Okay, if I will add a fund again. Okay, let's get all funders. I have here 3. I have here duplication of these addresses, but we'll resolve it in the next lecture. All right, guys, that's gonna be it. If you have any questions, keep asking, and I will see you in the next one. Cheers.